Hello everyone, in this video I'll be explaining the chemistry chapter of class 12, unit 10, haloalkanes and haloarenes. Firstly, moving into the chapter, let's do the basics first. Now, haloalkanes and haloarenes. Haloalkanes, the halogens, we have halogens, they belong to group 17 and they are represented by the symbol X, and we have fluorine, chlorine, bromine, and iodine. Now, these are the halogen atoms that we'll be studying in this unit. Now, the haloalkanes and haloarenes are known as the halogen derivatives of hydrocarbons. Now, in the haloalkanes, the halogens are referred as. For fluorine, it is known as fluoro, F-L-U-R-O, fluoro. For chlorine, it is known as CH, chloro. Bromine, it will be known as, the name will be given as bromo. And for iodine, it will be named as iodo. Now, let us study the halogen derivatives of our hydrocarbons. Now, if we study the hydrocarbon, in the hydrocarbon family, moving on to the basics first, we have aliphatic and aromatic hydrocarbons. Now, aliphatic hydrocarbons, they can be further classified into saturated and unsaturated hydrocarbons. Now, here our main focus will be on the saturated aliphatic hydrocarbons. Now, how do we get our haloalkanes in these saturated aliphatic hydrocarbons? Now, if we check saturated, we'll be focusing on carbon-to-carbon single bond. This is also known as alkane. Now, it has a general formula CnH2n plus 2, where n starts from 1, 2, 3, and so on. Now, suppose if we have when n equals to 1, we'll be having CH4. Now, in CH4 molecule, if one of the hydrogen atom is replaced by a halogen atom, that means if we have here CH4, if one of the hydrogen atom is replaced by a halogen atom, we'll be getting CH3X. That means this is known as, we'll be getting the product known as, and it is known as haloalkane. Now, our main focus in this unit will be on the saturated aliphatic hydrocarbons, from where we will be getting our haloalkanes. Now, furthermore, if you want to see what are unsaturated hydrocarbons, we will be having carbon-to-carbon double bond. They'll be known as alkene, ENE, having the general formula CnH2n. And then we have carbon-to-carbon triple bond. It is known as alkyne, ALK1 alkyne, having the general formula CnH2n minus 2. But in this unit, for our haloalkanes and haloarenes, we'll be focused only on the saturated aliphatic hydrocarbons, where we will be getting our haloalkanes. Now, moving on to our aromatic hydrocarbons. Aromatic hydrocarbons means the derivatives of benzene. Now, for a molecule to be aromatic, in class 11 we know that for a molecule to be aromatic, it should follow Huckel's rule. Huckel's rule, that is, it should have 4n plus 2 pi electrons. Now, where here our n starts from 0, 1, 2, 3, and so on. Now, if we have a benzene ring here, now in the benzene ring, if any of hydrogen atoms that is attached to the benzene ring is replaced by a halogen atom, we'll be getting here a structure in such a way, in this way. This is known as haloarene. Now, here, this structure, haloarene, is the one that we'll be studying in our unit 10, that is our haloarenes. Now, for us to understand this chapter better, is that the haloalkanes and haloarenes are known as, they are the halogen derivatives of hydrocarbons. Now, the haloalkanes that we will be studying belongs to saturated aliphatic hydrocarbons. That means there is only carbon-to-carbon single bond. And then the second one is the haloarenes will belong to our the aromatic hydrocarbons, that is, they are derivatives of benzene, following Huckel's rule, having 4 n plus 2 pi electrons. Now this is known as haloalkenes and haloarenes. Now this is the basics of our unit, haloalkenes and haloarenes. Now if we move on to the classification of our haloalkenes and haloarenes, we will be having one that they will be classified according to the number of halogen atoms attached. Number of halogen atom attached. That means, let's take the first one is monohaloalkene. That is, here it will have only one halogen atom, that means here CH3Cl, or we can take CH3CH2Cl. These are the examples of monohaloalkenes. Now if we take our monohaloarenes, what the example can be our benzene ring attached with one halogen atom. This is the examples of our monohaloalkene and monohaloarenes. Now if we move, we can check the second one. It's dihaloalkenes and dihaloarenes. Now dihalo means there will be 2 halogen atoms attached. Now if the 2 halogen atoms, since we are talking about 2 halogen atoms, we will be having 2 types of classification. That is, if that 2 halogen atoms are attached to the same carbon atom, there will be not that in that is H. If they are attached in this way, they will be known to the same carbon. If the 2 halogen atoms are attached to the same carbon atom, they are known as geminal dihalides, or it is also known as gem dihalides. And the second one is if the 2 halogen atoms are attached to different carbon atoms. That means we have here the example is CH2, CH2, R1X, the second X. The 2 halogen atoms are attached to 2 different carbon atoms. That means to the 2 vicinal carbon atom. It is known as VICINL, vicinal dihalides. It is known as vicinal dihalides. And in the same way, we can have dihaloalkanes and dihaloarenes also in this way. For example, our trihalo means 3 halogen atom attached. Means if we have here CH2, CH2, Cl. This is an example of our trihaloalkane, and for trihaloarenes we can have here our benzene ring, and to where 3 halogen atoms are attached in it. The position may differ according to the compound that we are specifying. Now this is the classification of our haloalkenes and haloarenes depending on the number of halogen atoms attached. Now the important part is here that the monohalogen compounds, the monohalo compounds are divided. They are classified into 2 types based on the basis of hybridization. Now it is 2 types, sp3 and sp2. On the basis of hybridization, our monohalogen means 2 halogen atoms. To how they are attached, they are further classified into sp3 and sp2 hybridized monohalogen derivatives. Now firstly, let's check our sp3 hybridized. Now this is classified into 3 types, 1, 2, and 3. The first one is known as alkyl, ALKYL, alkyl halide. This is the common name given to the monohalogen compound, alkyl halide, the common name. Now if you want, the IUPAC name will be haloalkenes. We'll be doing the nomenclature also, so for now let's just focus on the classification. Now this is known as haloalkene, or commonly it is known as alkyl halide. For example, that is RX. Now sp3 means the carbon atom to which the halogen atom is attached should be sp3 hybridized CH3Cl. The name here the carbon atom to which a halogen atom attached is sp3 hybridized, sp3 hybridized. Now the second one, ALLYL, allyl. The second one is known as allyl halide. Here we have the word allyl group. Allyl here is our allyl group is CH2 double bond CH CH2. This is the our allyl group, the formula for our allyl group. Now to this allyl group here, our allyl group here is, this is sp3 hybridized, sp3 hybridized, and the second carbon atom is sp2 hybridized. Now our halogen atom should be attached to this sp3 hybridized carbon atom. Therefore, for example, if we have a molecule here, CH2 double bond CH, CH2 Cl, this is an example of our halal halide. This is known as mid-8 prop 3 carbon atoms means PROPYL, propyl halide. Propyl halide H, or we can write CHLORID. It is also known as propyl chloride. Now the third one is, we will be having, the third one is known as benzyl, PENZYL, benzyl halide. Now in benzyl halide, remember the number of carbon atom is 7. Now benzyl means we know that it is a benzene ring here. Now if you remember in class 11 in hydrocarbons, we have discussed that all 6 carbon atom in benzene ring is sp2 hybridized, but our classification here is that the carbon atom should be sp3 hybridized. Therefore, if we attach one carbon atom here, second hydrogen atom, and to which the carbon atom where halogen atom is attached, here our carbon atom is sp3 hybridized, thus giving us our benzyl halide. This is known as an example of benzyl halide. This carbon atom is sp2 hybridized, this carbon atom is sp3 hybridized. This is an example of our benzyl halide. Therefore, on the basis of sp3 hybridized carbon atom, we have 3 types. The first one is known as alkyl halide, the second is allyl halide, and the third one is our benzyl halide. Now let's move on to our sp2 hybridized. On the basis of sp2 hybridization, we have only 2 types. The first one, let's discuss the first one. It is known as phenolic halide or vinyl halide, and the second one is known as our aryl halide, HALID. It is known as aryl halide. Now our aryl halide here, if vinyl group, the example of the formula of our vinylic group is CH2 double bond CH. This is our vinyl, the formula of our vinyl group. To this vinyl group, if an halogen atom is attached, it is known as vinylic halide. And the second one, aryl halide, our benzene ring is here. We know that all the carbon atoms in benzene ring is sp2 hybridized, therefore directly attached an halogen atom here. And therefore we get our aryl halide in this way. Therefore, on the basis of sp2 and sp3 hybridized, it is in sp3 we have allylic halide, alkyl halide, allyl halide, and benzyl halide, and in sp2 hybridized we have vinyl halide or vinylic halide, and the third one is aryl halide.